In this video, we will be discussing on the system design key concepts. This is part 2. In part 1, we have discussed on the first part, that is scalability. So in this video, we will be discussing on the availability. Firstly, we will discuss what is availability, what are the different availability tiers, what are the different strategies to improve the availability, and what are the best practices for high availability. So first one is, what is availability? Availability refers to the proportion of a time a system is operational and accessible whenever required, and it is always calculated in terms of percentage. That is, uptime divided by sum of uptime and downtime is availability. And what is uptime? That period during which a system is functional and accessible is uptime, and period during which a system is not available due to failures, maintenance, or any other issues, that is downtime. And what are the different availability tiers? Availability is often expressed in nines. The higher the availability, the less the downtime there is. And here each additional 9 represents an order of magnitude improvement in the availability. For example, 99.99% availability represents a tenfold improvement in uptime compared to the 99.9%. What are the different strategies to improve the availability? We have 5 strategies. First one is redundancy, second one is load balancing, third one is failure mechanisms, fourth one is data replication, and fifth one is monitoring and alerts. First one is redundancy. It involves having a backup components that can take over when the primary component fails. That is called as redundancy. And for redundancy, we have 3 techniques. First one is server redundancy, which can be like deploying multiple servers to handle the request, ensuring that if one server fails, others can continue to provide the service. That is server redundancy. Database redundancy can be like we can create a replica database that can take over if the primary database fails. That is database redundancy. And geographic redundancy is like distributing resources across multiple geographic locations to mitigate the impact of regional or localized failures. That is geographic redundancy. Second one is load balancing. What load balancing does, it distributes the incoming traffic across multiple servers to ensure that no single server becomes a bottleneck, and it will ensure or enhance both performance and the availability. And for load balancing, we have 2 techniques. First one is hardware load balancers, and second one is software load balancers. Hardware load balancers are the physical devices that distribute the traffic based on the pre-configured rules, and software load balancers are the software solutions that can manage the traffic distribution, such as HA proxy, or in the AWS it has cloud-based solution, that is AWS Elastic Load Balancer. These are the examples of software load balancers. Third one comes failure mechanism. Failure mechanism is like automatically switching to the redundant system when a particular failure is detected. So whenever there will be a primary service, and when the failure occurs, the request goes to standby service. That is failure mechanism. And for failure mechanism, we have 2 techniques. First one is active passive failure, and second one is active failure. Active passive failure is like a primary active component is always backed by a passive standby component, and that takes over the control when any failure occurs. And in active failure, all components are active and share the load, and if one fails, the remaining components continue to handle the load seamlessly. This is failure mechanism techniques. Fourth one is data replication. Data replication involves the copying of data from one location to another to ensure that the data is always available if any one of the location fails. And for data replication, we have 2 techniques. First one is synchronous replication, second one is asynchronous replication. Synchronous replication is data is replicated in real time to ensure the consistency across all the locations. And asynchronous replication is like data is replicated with somewhat delay, which can be efficient but may result in slight data inconsistencies. So these are the 2 data replication techniques. Fifth one is monitoring and alerts. Continuous we should always do the continuous health monitoring of the systems, which involves checking the status of system components to detect the failures early and trigger alerts for any immediate action. And for monitoring and alerts, we have 3 techniques. First one is heartbeat signals, second one is health checks, and third one is alerting systems. In heartbeat signals, regular signals are sent between the components to check the status of that component. So we will come to know whether there is any issue or not. And in the health checks, automated scripts or tools that perform regular health checks on that components that will be performed. And alerting systems are like there will be some tools like PagerDuty which will notify the administrators for detected issues. So these three are the techniques for monitoring and alerts. Then comes to design the high availability system, what are the best practices? So we have 7 best practices. First one is design for failure. Whenever designing any system, we should always assume that any component of the system can fail at any time, and we need to design the system accordingly so that it can handle the request though that particular component get failed. Second one is implement health check. It is like we should always do regular health checks which allows us to detect and respond to the issues before they become critical failures. Third one is use multiple availability zones. We should distribute our system across different data centers to provide the localized failures. And fourth one is practice chaos engineering. What is meant by this? Like we should intentionally do some failures in our system to test the system's resilience. So it will be from our end itself. We will include some breakage in our system, and we will check whether the system is able to handle it or not. Fifth one is implement circuit breakers. Let's say if any particular in between component get fails, then we should prevent the cascading of failures by quickly cutting off that particular problematic service which is in between, that is implement circuit breakers. Sixth one is use caching wisely. Caching can always improve the availability by reducing the load on backend systems, so we should always use caching wisely. And second one is plan for capacity. We should ensure our system can handle both expected and unexpected load in increase, and accordingly we should plan for capacity. So by using these 7 best practices we can design the high availability system. And actually availability is critical aspect of system design which will ensure that user can access the service reliably and continuously. So by implementing the strategies which are discussed in the previous slide, like redundancy, load balancing, failover mechanisms, and data replication, we can design highly available systems, and these are the 7 best practices for high availability. Thank you.